This is Dr. D. Govardhan, Professor in the Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are discussing the tutorial question bank on Module 2, Friction in Engineering Mechanics. Look at problem number 1. A body is resting on a rough horizontal plane required to pull off 180 newtons, inclined at 30 degrees to the plane just to move it. It is found that a push of 220 newtons, inclined at 30 degrees to the plane just to move the body. Determine the weight of the body and the coefficient of friction. Okay, the given data from the problem is the pull is equal to, first we are taking 180 newtons at an inclination of 30 degrees, which is acting on a body resting on a horizontal plane as shown in the figure. When we are drawing the free body diagram for the body, the weight is acting vertically in downward directions and the normal reactions acting upward directions, and the friction between the body and the plane is experienced always in opposite directions in which the body tends to move. Here, according to the force 180, it is acting toward the right hand side, hence the friction force is acting toward the left side as shown in figure. When it is about to move means the forces which are acting on the body are treated as here in equilibrium position. Here we are considering a pull of 180 newtons acting toward the right hand side. The friction force is acting toward the left side. Here, according to this problem now, friction force is equal to, that is the sigma horizontal force is equal to sigma h is equal to, we can take it sum of the horizontal components which are acting on a body, which is equal to 180 minus 180 cos 30 positive minus f1, it should be equal to 0 now. That is, from this relationship we got to f1 is equal to 180 into cos 30 degrees now. So which is equal to cos 30 is equal to 0.866, which is equal to 155.9 newtons. Okay, this is called here now the frictional force which is experienced between the contact surfaces when 180 newton force is acting on the body to move the body toward the right hand side. Now the sum of the vertical component of forces is equal to the W is acting downward direction is treated as negative. The force, that vertical force, which is acting again in upward directions, again it is treated as a positive. N1 is a positive, that is N1 as well as the 180 sin 30 both are acting upward directions. The weight is acting downward directions. Okay, from this relationship we have N1 is equal to W of minus 180 sin 30 degrees. From this region W is minus of 180 to 0.5, which is equal to W minus 90 newtons. But the friction force is equal to, we are having F is equal to mu into N, where mu is the representing coefficient of friction between the contact surfaces and N1 is representing normal reactions. It can be written as now friction force is equal to mu into W minus 90 degrees, which is equal to equation number 1 now. Similarly, when the push force of 220 newtons is acting on it, as shown in figure, Because of this force, the body tends to move toward the left hand side. Hence, the friction force always acts toward the right hand side as shown in figure. The weight is acting downward directions and normal reaction is the upward directions. The pull force is making an inclination of 30 degrees with the horizontal. When it resolves into two components, so 200 sin 30 is acting downward direction, so 200 cos 30 toward the left hand side as shown in figure. Here the body is again about to move, that means it is treated at the equilibrium position. That means the sum of the forces which are acting along the x direction should be equal to 0. Similarly, the algebraic sum of the forces acting in y direction also equal to 0. When you are taking horizontal directions, that is F2 should be equal to 200 into cos 30 degrees, which is equal to 190.25 newtons now. Similarly, when the forces are resolved into vertically, that is the upward forces are treated as positive, downward forces are treated as negative. Hence, N2 is equal to, we can take it as W plus 220 into sin 30, which is equal to W plus 110 newtons. But F is equal to, we are having mu into N now. By using these relations, 190 minus 0.5 is equal to mu into N2. Mu is equal to, N2 is equal to W plus 110 is given. By solving the equations of 1 and 3, this we got to, this mu is equal to, here W is equal to, we got to 991.2 newtons. Similarly, mu is equal to 0.173. This is the value of a coefficient of friction. It is not at all having any units. Problem number 2 now. Two blocks A and B of weights 1 kilonewtons and 2 kilonewtons respectively are in equilibrium position as shown in figure 2. If the coefficient of friction between the two blocks as well as the block B and the floor is 0.3, find the force P required to move the block B now. Here the given problems, the given data in the problem is the weight of the block A is equal to 1 kilonewtons given, and weight of the block B, that WB is equal to 2 kilonewtons. The coefficient of frictions between the floor and the block B is equal to 0.3 is given. Now, in order to solve the problems, first of all, draw the free body diagrams individually for the blocks A and B. When I am drawing this free body diagram for the block A now, the forces are acting on the block A equal to 30 degrees, that T is acting, that force T is acting at an angle of 30 degrees. N1 is acting upward directions now, and the weight is acting downward directions. Since the body tends to move toward the right hand side, the friction force F1 is existing toward the left hand side as shown in figure. Now result of forces vertically, we got N1 plus T sin 30 equal to 1 kilonewtons. From this relation we got T sin 30 is equal to 1 minus N1. It is represented as equation number 1. Similarly, resolve the forces horizontally. We got T cos 30 is equal to, here now, T cos 30 is equal to F1. F1 is equal to mu into N1, which is equal to 0.3 into N1. By solving the equation number 1 and 2, we got N1 is equal to 0.285 kilonewtons and F1 is equal to mu N1, which is equal to 0.255 kilonewtons. Now consider the block B now. The total weight here now, the reactions is equal to upward directions N2. The total weight is equal to, here now, 2 kilonewtons plus N1 is also acting downward directions. That is N2 is equal to 2 plus N1 is equal to 2 plus 0.85 equal to 2.85 kilonewtons. And F2 is equal to mu N2, which is equal to 0.3 into 2.85 kilonewtons is given now. When the result in the forces horizontally on block 2, we are having here now the block 2 is nothing but the friction force is there, F1, it is acting toward the left side. Here F2 is also acting as shown in figure now. That is, both are acting in the same direction. So P is the force that is acting here now, P. That is P is equal to F1 plus F2. Because the block 2 it is there now, it tends to move the body toward the left hand side, and the friction force is acting toward the right hand side as shown in figure. P is equal to F1 plus F2 is equal to 1.11 kilonewtons. R, which is equal to, from this relation we got, theta is equal to tan inverse of 0.2, which is equal to 11.309 degrees now. So if P minimum is required now, which is equal to P least is equal to 164.9 divided by cos 11.309 plus 0.2 into sin 11.309 degrees now, here which is equal to 161.88 degrees. That is the value of minimum force that is required to move the body or to move the system of bodies about to move. Okay, effect of frictional forces in connected bodies. A cord connects two bodies of weights 300 newtons and 800 newtons. Here, which is equal to 300 newtons and 800 newtons. These two bodies are placed on an inclined plane and the cord is parallel to the inclined plane. The coefficient of friction for the weights of 400 newtons 0.15 and that for 800 is 0.4 now. A cord connects two bodies of weights, it is the 400 newtons and 800 newtons now. Determine the inclination of the plane to the horizontal and the tension in the cord when the motion is about to take place down the inclined plane. The body is weighing 400 newtons is below the body weighing 800 newtons. That is according to the figure now. The W1 is equal to 400 newtons and W2 is equal to 800 newtons. Both are connected together by the string as shown in figure. We have to determine the values of alpha, that is the inclination of the plane with the horizontal. The coefficient of friction between the 400 newtons and inclined plane is 0.15 and 800 newtons and inclined plane is 0.4 now. This is the given data for this problem now. Let N1, N2 are representing the normal reactions and F1, F2 are representing the frictional force experienced between the bodies and the inclined plane. As the motion of the two bodies is about to take place down the inclined plane, now when we are drawing the free body diagram for the block 1 weight is nothing but it is equal to 400 newtons, that in downward directions. Normal reactions perpendicular to the plane. Since the body tends to move downward direction, frictional force is acting upward directions F1. So the force is the weight of the body is resulted in two components. So W sin alpha acting toward the downward directions and W cos alpha is acting in downward directions with respect to the inclined plane now. Now when the forces are resolved along the plane now, 400 sin alpha is acting downward directions, it is equal to, here T is representing tension in the string which is always away from the object, that is according to the problem it is acting toward the right hand side. So T plus F1 which is equal to T plus mu into N1 which is equal to T plus 0.15 N1. Similarly, when the forces are resolved normal to the plane now, W1 cos alpha is acting downward directions, normal reactions are upward directions, hence 400 into sin alpha is equal to 400 into cos alpha is equal to N1. So, from this really substituting the values of R1 in the equation number 1, we got to 400 into sin alpha is equal to T plus 0.15 plus into 400 cos alpha. From this relation, we got T plus cos alpha, 60 cos alpha, or T is equal to 400 sin alpha minus 60 cos alpha. The forces which are acting on the second body, that is the W2 is equal to 800 newtons. Here the body again tends to move in downward directions. The tension is acting for this body is in downward directions. The forces are normal into the normal reactions are perpendicular to the plane. F2 is along the plane, but it is acting in upward directions. The weight of the body is the result in two components. So W2 sin alpha act in downward directions. So W2 cos alpha perpendicular to the plane. It is there. It is balanced by normal reaction same to now. Hence, when the forces are resolved along the plane, so we got 800 into sin alpha plus T, both are acting downward directions, so it should be equal to the F2. F2 is equal to mu 2 N2, it is equal to 0.40 into now. Similarly, resolve the forces normal to the plane now, that is N2 is equal to 800 cos alpha. So substitute the values of R2 is in the equation number 3. We got to T is equal to here now 320 cos alpha minus 800 sin alpha. From equation number 2nd and 4th, we got T is equal to alpha is equal to 17 degrees 34 minutes now. Similarly, T is equal to 63.48 newtons. Okay, the application of the frictions. Here we are taking lateral friction. Here the problem is a ladder 5 meters long rests on horizontal ground and leans against the smooth vertical wall at an angle of 70 degrees with the horizontal. The weight of the ladder is 900 newtons and acts at its middle. The ladder is at the point of sliding. When the man weighing 750 newtons stands on a rug 1.5 meters from the bottom of the ladder. Calculate the coefficient of friction between the ladder and the floor. Length of the ladder is equal to, is given 5 meters now. The angle with which the ladder makes with the horizontal is equal to 70 degrees. The weight of the ladder is equal to 900 newtons. The weight of the person is equal to 750 newtons. The distance between the man and the bottom of the ladder, it is given 1.5 meters now. Let mu is representing the coefficient of friction between the ladder and the surface of the ground. Na is representing normal reactions at a point A. And at B point, since it is resting against the smooth vertical wall, the friction force is equal to 0. NB is representing the normal reactions. It is acting here now in horizontal. Okay, resolve the forces in horizontal directions. In horizontal directions, only two forces are acting, FA toward the right hand side and NB is toward the left hand side. Hence, FA is equal to NB is represented in equation number 1. Similarly, resolve the forces into vertically. In vertically, NA is acting upward directions. The weight of the ladder is acting downward directions. The weight of the person is also acting downward directions. These three forces are there. The upward forces are positive, downward forces are negative. When it is equilibrium position, the sum of the forces are acting upward directions will be equal to the sum of the forces are acting downward directions. Hence, according to this problem, NA is equal to 900 plus 750 is equal to 1650 newtons. Hence, FA is equal to the coefficient of friction is equal to, we can take it as VA into 1650 now. Now, the third equation we are taking the moments at a point A, that is the moments created by the system of forces at any point should be equal to 0. Here, the preferable points are A and B, where it is having more than one unknown quantities are there. Hence, we are taking just at A point is the preferable point here now. It is equal to the NB is there now. This force tends to slide the body in counterclockwise directions, and weight is clockwise directions. The weight of the person is also clockwise directions. Hence, the sum of the moments in clockwise direction should be equal to the sum of the forces acting in anti-clockwise direction. Hence, NB into 5 sin 70 equal to 750 into 1.5 into cos 70 plus 900 into 2.5 into cos 70 degrees. From this relationship, we got to NB is equal to 1849 1849.5 newtons. Similarly, FA is equal to mu into NB, here which is equal to 246. F is equal to N into B now, which is equal to 675 divided by tan B, tan 70, which is equal to 246.35 newtons. Similarly, FA is equal to mu A into NA, mu A into 1650. From this relation, mu A is equal to, that is the coefficient of friction at a point A is equal to 0.15. Okay, the problem on wedge friction now. A block weighing 1500 newtons, overlying a 10 degrees wedge on horizontal floor and leaning against a vertical wall, is to be raised by applying horizontal force to the wedge. Assume the coefficient of friction between the wall surface and contact to be 0.3. Determine the minimum horizontal force required to raise the block. The given that in the problem is the weight of the block is given 1500 newtons. Angle of wedge is equal to 10 degrees. The coefficient of friction between all the contact surfaces equal to 0.3. R, which is generally represented as a tan pi, it is equal to pi is equal to 16.7 degrees now. Now consider the equilibrium of the block now. Here the forces which are acting on this block are now here. Since when the force is applying on a wedge, the weight of the body is assumed to be passing over the wedge now toward the right hand side. But at the same time, it is also raising now against the vertical wall. The force, frictional force experienced between the vertical wall and the weight of the bodies, because the body is just moving in upward directions, the frictional force is acting in downward directions. It is a normal reactions. The weight is acting in downward directions. Here, the reactions at the bottom, it is now resolved into two components now, horizontal and vertical. Similarly, the frictional force is there now. Since the body is moving in upward directions now, it is acting in downward directions now. Again, when it is resolved into two components, horizontal component and the vertical component represented as shown in figure. Now, for the weight W, when the force is resolved in horizontal directions, that is sigma fx is equal to 0, we are having N1, it is there towards the left side, towards the right side, positive, N2 sin alpha, it is the negative, minus F2 sin cos alpha, it is also negative because both are acting toward the left hand side now, equal to 0. From this relation, N1 minus N2 sin 10 degrees minus of 0.3 N2 cos 10 is equal to 0 now. From this relation, we got N1 is equal to 0.47 N2 now. The algebraic sum of the component of forces acting in the y directions, that is vertical directions. Here F1 is acting downward directions. The weight is acting downward directions. The N2 component of N2 is acting upward directions. The component of friction force is acting downward directions. Hence, here now F1 here it is equal to F1 upward directions positive, N2 cos alpha to the upward directions minus of F2 sin alpha minus W is equal to 0 now. 0.3 into F1 is equal to mu into N1 0.1 plus N2 into cos alpha is equal to 10 degrees is given now, which is equal to 0.985 minus of F2 is equal to 0.3 into N2 into sin alpha is equal to 0.174 minus weight is equal to 1500, it is equal to 0. From this relation we got to 0.3 N1 plus N2 into 0.9328 minus 1500 is equal to 0. From equation 1 and 2 now, we got N2 is equal to 1396.65 newtons, F2 is equal to 419 newtons, N1 is equal to 642.33 newtons, and F1 is equal to 192.27 newtons. Now we are considering the wedge now, the forces which are acting on it. The normal reactions there N2 it is acting for this wedge in downward directions. The friction force is acting toward the right hand side, and the friction force between the wedge as well as the horizontal surfaces, because the wedge is moving toward the left hand side, the friction force is acting toward the right side as shown in figure. Here it is represented in 3 normal reactions upward directions. P the horizontal force that is acting, it is acting toward the left hand side now. So when the taken sum of the forces which are acting along the x direction is equal to F3 positive, N2 sin alpha plus F2 cos alpha minus P is equal to 0. From this relation we got 0.3 into N3. N2 sin alpha is equal to 1396.65 into sin 10 degrees. F2 is equal to again now F2 cos alpha, which is equal to 0.3 into 1396.65 into cos 10 minus P is equal to 0 degrees. From this relation N3 is plus 243.02 plus 412.71 minus P is equal to 0 now. From this relation, so finally we got to 0.3 N3 plus 655.73 minus P is equal to 0. This is the equation number 3. Similarly, resolve the forces in horizontal directions. That is sigma Fi is equal to 0. Here the horizontal forces are, one is given here now, vertical forces. The vertical forces is the N3 upward directions. Resolve the forces in y direction, that is vertical directions. Here N3 is acting upward directions now. The component of N2 is acting downward directions. The component of friction force F2 is acting upward directions. It should be equal to 0 required now. Hence, we can take N3 minus N2 cos alpha plus F2 sin alpha is equal to 0 now. From this relation, we got N3 is equal to 1273.04. By using equation number 1 and 4, we got P is equal to 1037.64 newtons. This is our required answer. That is, by using the wedge, we can determine what is the minimum force P that is can be applied on the wedge, so that the objects can be moved upward directions. The main application of the wedge is used to lift the heavy load at a smaller distance, particularly industries where the assembling of heavy parts is required. Now screw jack. It is generally called screw friction now. The application of screw friction. The screw jack is used to lift the heavy load or lower the heavy loads by applying minimum force or the effort at the end of the lever. Here it consists of one is it is known as a screw now, square threaded screw, which can be moved just into the nut. The nut is treated as in most of the cases the integral part of the body of the screw jack. The top of the screw threaded rod, it is having head. Generally, at equal space slots are provided for inserting that lever so that it can be rotated in clockwise direction and anti-clockwise directions. This over the head of the square threaded rod, a freely rotated cup is provided over it. The weight is placed, which can be lowered or lowered. It can be depending upon the rotation of the screw directions. Is the problem of 11 these deals with the screw jack only. The main radius of the screw of a square threaded screw jack is 25 mm. The pitch of the thread is 7.5 mm. If the coefficient of friction is 0.12, what effort applied at the end of the lever, 60 centimeters length, is needed to raise the weight of 2 kilonewtons. The given that in the problem is mean radius of the screw is given 25 mm. Pitch of the thread is given 7.5. Coefficient of friction is equal to 0.12. Generally, it is represented tan pi. Length of the lever is equal to 60 centimeters. The weight to be raised, that is W is equal to 2 kilonewtons, which is equal to 2000 newtons. Let P1 is representing the effort that is applied at the end of the lever, and alpha is an helix angle. Then tan alpha is equal to P by pi d. P is equal to 7.5 divided by pi d. D pi into 25, which is equal to 0.48. The effort required at the main radius of the screw to raise the weight is given by P is equal to tan alpha plus pi, which is equal to, on expansion we got tan alpha plus tan pi divided by 1 minus tan alpha tan pi. By substituting the values of here now, 200 into, that is 0.12 plus 0.048 divided by 1 minus 0.12 into 0.048. From this relation we got to 338 newtons. Now the effort applied at the end of the lever is obtained by taking the moments. That means that the P1 is nothing but here now. P1 into 60. P1 is representing the load which is applied at the end of the lever, 60 centimeters is equal to P into 2.5. From this relation we got P1 is equal to 14.21 newtons. Now the second problem, a screw jack of square threaded with 2 threads in centimeter. The outer diameter of the screw is 5 centimeters. If the coefficient of friction is 0.1, calculate the force required to be applied at the end of the lever, which is 70 centimeters long. First, to lift the load of 4 kilonewtons and to lower it now. Outer diameter of the screw is given now, that is 5 centimeters given. Coefficient of friction is equal to mu is equal to 0.1, which is equal to tan pi, we can take it as. Length of the lever is equal to 1 is equal to L is equal to 70 centimeters. Load to be lifted is equal to 4 kilonewtons, which is equal to 4000 newtons. There are 2 threads in centimeters, that is N is equal to 2 now. Therefore, the pitch of the screw is equal to 1 by 2. It is equal to 0.5 centimeters. Internal diameter of the screw is equal to 5 minus 2 into 0.5, it is equal to 4 centimeters. Mean diameter of the screw is equal to 5 plus 4 is nothing but 4.5 centimeters. Alpha is representing helix angle now. Tan alpha is equal to P divided by pi d, which is equal to 0.0353 now. The force required at the end of the 70 centimeters lever to be lifted. The P1 is the force required at the end of the lever to be lifted. The force required to be applied at the main radius of the lift to lift the load is given by P is equal to W into tan alpha plus pi, which is equal to W into tan alpha plus pi is equal to tan alpha plus tan pi divided by 1 minus tan alpha tan pi, and substituting the values of W is equal to 4000, tan alpha is equal to 0.0353 plus tan pi is equal to 0.1, we got P is equal to 543.1 newtons. Similarly, the force required at the end of the 70 centimeters long lever to lower the load now. Assume P2 is representing the force required at the end of the lever to lower the load. Then P is equal to, we can take it as a W into tan alpha minus pi, which is equal to W into tan alpha plus pi is equal to tan alpha minus tan pi divided by 1 plus tan alpha plus tan alpha into tan pi. From this relation, we got to 257.9 newtons. Now, the force required at the end of the lever may be obtained by using the principle of moments. That is, the moments created by the force which is applied at the end of the screw should be equal to the moments created by the force at the end of the lever, which is equal to P into D by 2 is equal to P1 into L. From this relation, we got P1 is equal to 8.3 newtons. That means we can determine the force which is required at the end of the lever to lift the load or lower the load is by using these equations. Screw job. As a thread of 10 meters pitch, what effort applied at the end of the handle, 400 mm long, will be required to lift the load of 2 kilonewtons if the efficiency of this load is 45%. So the given that in the problem is pitch of the thread is equal to 10 mm, length of the handle is equal to 400 mm, load lifted is equal to 2000 newtons, 2 kilonewtons. The efficiency of the screw jack is given 45% is equal to 0.45. P is nothing but assume just effort required to lift the load. The velocity ratio it is equal to 2 pi L divided by P, that is the distance moved by the effort to the distance moved by the load. Now, the distance moved by the effort is nothing but from cycle, the distance covered is equal to pi L. When it is rotating one entire cycle, the load is moved a distance of pitch only, that is P is, which is equal to 2 pi into 400 divided by 10, which is equal to 251.3 now. Mechanical advantage is equal to the weight lifted divided by effort applied, which is equal to 2000 divided by P. So, the efficiency is equal to, it is the ratio of mechanical advantage to velocity ratio. By using this relations, we got to efficiency is equal to 0.45 is equal to mechanical advantage is equal to 2000 divided by P. Velocity ratio is equal to 251.3. From this relation, we got to P is equal to 17.27 newtons. Okay, these are the important problems collected from the friction as well as their applications in screw, ladder, and bench. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.